Let's start this problem by distributing that negative 5 through that set of parentheses here. So we are going to get 11x, and then negative 5 times positive x is negative 5x, and then negative 5 times negative 3 is plus 15. That's all equal to 6x plus 5, nothing to combine on the right side. But then the 11x minus 5x, we can get a 6x plus 15 equals 6x plus 5. Now notice we've got x's on both sides. I've got just as many on the left as I do on the right, so it doesn't matter what side you're going to try to get these on. Maybe I'll get them on the left side. But something interesting is going to happen here. You'll see. So let's subtract this 6x, right? So here's the plan. Let's subtract that 6x. But when we do that, here's what's going to happen. Now I'm going to write all this out. So we're going to get 6x plus 15 and then minus 6x on that side equals 6x plus 5 minus 6x. And then when we combine 6x minus 6x, that's 0. No more x's. So we're left with 15 equals, and then 6x minus 6x is 0. We're just left with 5. So now we're left with this statement that 15 is the same as 5. Well, that's false. We know that. That's false. Now here's what we can do. We've eliminated all the variables. So when you're solving an equation, if you eliminate all the variables and are left with a false statement, what that means is there is no solution to this problem. This equation has no solution. That means there's no value, no number at all that we can put in for x to make this side equal to this side. And this is going to happen. You get no solution when you eliminate, right, do everything you're supposed to do, eliminate all the variables and get a false statement. No solution. I mean, does that make some kind of sense here? Look what's happening here. Back up, where can we go here? How about if we go, say, right here? Look at this. X is some number. Now, what number do you know, right? So if x is a number, 6x is just a bigger number, probably. So you have a number here and the same number here. Do you know of any numbers that you can add 15 to it and then add 5 and you get the same number? No way. You can't add 15. You can't just pick any number and add 15 and 5 and think you're going to get the same number. So right from here, you can tell that there's no solution. Number 10, I'm going to start by multiplying through here and to eliminate those parentheses. So doing so will give me, now 2 times 5x is 10x. 2 times positive 20 is plus 40 equals 6 times 2x is 12x. 6 times positive 4 is 24. And I see I've got x's on both sides, so I'll use the side on which I have more x's already. I've got 10 on the left, 12 on the right, so I'm going to get all the x's on the right. So let's get rid of these. I've got positive 10x, so let's subtract 10x. So I'll just say what I'm going to do. I'm going to subtract that 10x. So if I do that, I will get 10x, right from here I'll get 10x minus 10x, no more x's. We'll get 40 equals, now 12x's minus 10x's leaves us with 2x's plus 24. Now we need to do two things. Eliminate the 2 and the 24, but in what order? Addition, subtractions, eliminate first, and then multiplications, divisions. So let's subtract that 24. So the plan is to subtract 24 right there. So let's do it. So 40 minus the 24 is a 16 equals 2x, and then 24 minus 24 is 0. Divide by 2, and we will get x equals 8 for our solution. Let's eliminate these parentheses. So I've got 2 sets of parentheses, and both of them are preceded immediately by a minus sign or a negative sign. This is a negative, this is a minus. But in both cases, I know I can just eliminate the parentheses by distributing the minus or negative through. Change the sign of every term in the parentheses. So I'll get negative 4y minus 1, right? Negative, negative. And then here, change these signs. So that'll give us plus 3y plus 4 all equals 1. Negative 4y plus 3y is just negative 1y, negative y. And negative 1 plus 4, well, that's a 3. That's equal to 1. Let's subtract the 3, right? Let's subtract that 3. So we'll get negative y equals, now, where are we? 1 minus 3 is negative 2. But this says the opposite of what I want, right? I want y. This is the opposite of y. The opposite of what I'm looking for is negative 2. So what am I looking for? This is the opposite of what I want is negative 2. So I must be looking for 2. Or if you like, why don't you just maybe multiply or divide by negative 1. If you multiply or divide by negative 1, we're going to get y equals to 2 as our solution. Let's eliminate these parentheses. I'm going to multiply through, right? We'll distribute. So we'll get 5 times 3x is 15x. 5 times negative 15 is negative 75. And this is equal to, all right, distribute, 15x. 15 times negative 5 is negative 75. Now look, you notice this, right? This side is identical to this side. So it seems like no matter what you put in for x, this side, the left side, will be identical to the right side. Let's just see what happens if we keep going. So there's going to be an interesting feature to this. Let's get all the x's on one side. So maybe I get them on the left side. Doesn't matter, I've got 15 on each side. So I'm going to subtract 15x. Subtract 15x, right? Maybe I'm subtracting that one. So if I do that, I will get 15x minus 15x is 0. The x's are gone. I get negative 75 equals, and on the right side, if I subtract 15x, I get negative 75. Now, this happens to be a true statement. So let's make a comparison now. Look back here to what we did in problem number 9. We went through our work, we eliminated all the variables, and we got a false statement. Now, if you eliminate all the variables and get a false statement, you've got no solution. But over here, what did we do? We went through our work, and we eliminated all the variables, but we got a true statement. So what this means is there is no unique solution. There's infinitely many solutions. We can put any value in for x, and this side will be the same as this side. So I'm going to write this as no unique solution. That's the way I write it. There's infinitely many solutions. Textbooks may write it a different way, but I'm going to say there's no unique solution here.